Alright, hello everyone, welcome to the new section on computer vision. So in this section, we plan to provide you with a brief introduction about the materials in computer vision in this area. Normally, if you take a course on computer vision, it will take probably more than 1 year for you to know some basic information about this domain, this area. You need to know the basic problem study as well as some methods there. Right? However, in this lecture, we plan to provide you with a very brief introduction about this area with only one single class. So here's the outline for today's talk. At the very beginning, we'll talk about what is computer vision, and we also do a brief introduction about the vision system in our human beings. And then we will talk about what are the problems studied in computer vision in this area, as well as the computer vision with deep learning, and how to do the computer vision via deep learning models we have introduced before or to be introduced in the following lectures. So at first, what is computer vision? Computer vision is a science and technology that make a machine can see. So it is concerned with the scenario for building artificial systems that can obtain information from images. So the images data studied in computer vision can be very diverse in different formats. And we show you with some examples. We can have the regular black-white images, the grayscale images, or the color images in RGB, right? In RGB coding for the pixels. Besides the regular images, we also have some other data formats which can also be viewed as images, like the videos. Even though we think the video is different from the images, however, if you know the video data, actually it contains of many different frames of the images, which will be in a sequence, right? So normally, if there will be at least 24 frames of the images per second, then our eyes will not be sensitive to the transition among images, and we will see them as a smooth movement. Of this objects inside the videos, right? And we will think they will be more like videos instead. However, this video, their reality, representation will be the sequence of images instead, and normally they will also be associated with some audio, right, information there. And besides the videos, we also have some other images which are like a depth image instead. So if you know that for safe driving, right, many of the cars will be installed with this LiDAR, right? LiDAR actually is one device for the remote sensoring. So this LiDAR will be sent out a bunch of like a laser torch, right? And once there will be object in the front, then there will be a reflection. And this device can receive the reflection, to sense the objects, nearby. So data we can get from LiDAR will be more like a point of cloud, right? We will have so many clouds, via the reflections, so we can sense objects, nearby. And for this kind of data, it is very different for images. However, we can also view them as image data as well, which will be a crowd of points instead. Besides LiDAR, there will also be some other data which will be very different from images. However, we can also treat or deal with them via as images instead. For example, we can have some high-dimensional medical scanning images like CT. If you do the CT, right, normally it will be a 3D scanning of our brain or some other organs inside our body, right? However, if we do the scanning over time, we can view the activity of our organs right inside our body. Then we can have a time series of the scanning of the organs in our body instead. So it will be very different from the image we show above. However, we can also deal with them as image as well. And if you still remember, in the previous lecture, we have talked about how to represent the images, right? And for the regular images, like a black-white image, grayscale image, or the color images, we can represent them as matrix. So for the black-white image, it will be very easy, right? We can represent this image as a binary matrix, and we can use this 0 or 1 to denote either black or white, these corners inside the input image, right? In this way, we can transform this input image into a binary matrix. We can use 1 bit to represent 1 pixel inside the image, right? And for the grayscale image, we can also represent it as a matrix. However, here we will use 1 byte to represent 1 pixel instead. So we can assign a value for each pixel inside the grayscale image. And this pixel, this value will be inside the range from 0 to 255 instead. So we can use 1 byte to represent 1 pixel and transform this grayscale image into 1 matrix, like shown in this one, right? It will be very similar for the color images. We can also provide the RGB coding for each pixel inside the color image, right? In other way, we can transform this color image into this RGB matrix for the image instead. And we can use 3 bytes to represent 1 pixel, in terms of red, green, and blue as colors. So each pixel inside the image will be represented as 1 value in the range from 0 to 255 instead, right? So this will be the matrix representation of these color images. And besides this one, we can also have the high-dimensional image tensors, right? As we mentioned before, for the scanning of our brain or organs, then we can represent the scanning result as this like a high-dimensional images. For each timestamp, we can have one 3D scanning of our brain, for example. However, if we do the scanning over time, then we can have multiple brain scanning, 3D brain scanning images over time. Right, it can be represented as a high-dimensional tensor, right? And we have 3-dimensional for each timestamp. However, we have multiple timestamps instead, right? Alright, so this is about computer vision, this area and how to represent images. And then next, before we talk about the computer vision problems as well as methods, we can first talk about the human being, this is our vision system first. And it can provide you with some background knowledge for this area.